Okay, because she has to take 30.
Bailey?
And we already
Doing really good things.
but it's like maybe it's like half on because I had it and then they turned it to get off because my parents were weird. That's so weird. Oh, are you transferring extra from? That's like
So guys, I found out from the Math Science Center the specific times that there's going to be a tutor who can tutor this class. We talked about it last time how math majors don't have to take this class, obviously, so not every math tutor is going to feel comfortable. There are a few tutors who have taken this class, and so this is the times when they're there. It's almost full coverage. Just Tuesdays in the morning there's not any. So every time after this class, you can go right to the Math Science Center, and there's a tutor in there that can help you. You guys okay? Just when you go in there, you're gonna say, "I need Math 125 help," because there's only one tutor that can help at those times. I guess that makes sense. Not every tutor can do it. We're going to actually do chapter 2 today. Last time we didn't do that, but before we can do that, we need to finish that paper from last time. So does anyone, I think there's a couple of you that just enrolled that needs this. I've only got 3 more sheets here. Let's see if my memory works. You need one. Who's the other person that just? You. And then, does anyone else need a copy? I got one more. You. Okay. Bum, 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 bum. How's things going here? We're at the end of the first week. How's all your classes? Is it okay? Yeah? Next week's supposed to be a little cooler. Thank God. But to be really honest, the AC is working way better than it ever has. There was one semester when it was like 78 in here. I know. Let's get out of here. Okay. Last time we left off here. So we didn't do these guys yet. Everybody's favorite, some algebra down here. If you can dredge this back up from last time, did anybody do this problem here? Yes, what'd you do?
I subtracted 4 from 5x to get rid of it.
So you took the 4x.
Yeah.
So you effectively got all your x's together on one side. So this -2 is still there.
And then I took the 3 and took it to the other side.
Sweet. So in general, you want to get all your variables on one side, all of the numbers on the other side. And then the last thing you almost always do is divide if you have to. But in this case, when I add 3, what's -2 plus 3? 1. Sweet. Yeah. And then you can check it. If I plug a 1 in, 4 times 1 minus 2 is 2. 5 times 1 minus 3 is 2. Yay, it works. It's equal to each other. Yes? Sweet. Now listen. In this class, we are going to talk about algebra, but it's like chapter 9. Are you with me? So I'm not, in the context of this class, we're not going to do this for a while, but in the context of where you should be coming from, you should have worked with solving equations. So I just want to see where we were with that. Did anyone try part B and number 3? You did?
Yeah.
Anybody else? I want to see. You did? You did? Did you get to a weird place?
Yeah.
Okay, good. Because it's supposed to get to a weird place. So what's a good first step on 3B? Yes?
To distribute.
And when you distribute, you can make whatever sound effects you want to. 2x. Okay. And the next step is always, if you have any like terms, get them together. So the only like terms I have on either side are what? What are my like terms? Yeah, this goes together, becomes 3x. And already you can see this is weird. But if I just plow forward, and right here, why did you subtract 4x? So you can get all your x's on that side. So what would I do? I subtract 3x, yes? And what always gets me, what always strikes me as funny is students hate x. You're like, why do you have to bring x in this shit? Just leave it as numbers. But then students want to save. Look. Don't the x's die? But then students always right there, like they're trying to save it. No, let it die. It's been around for a while. It's like, let me rest. Die. So what's left here? And then you stare at that, and you're like, what the shit does this guy want me to do with this? Let's really analyze what this means. What does this mean? And you're going to say, well, Jeff, it means that x is 1. But what is, in the context of the problem, what's it mean? 1 is the solution. Now stretch that out a little bit. This equation is true if this is true. So let me say that the other way. When x is 1, then that equation is true. You guys with me? Okay, now watch this. Do the same thing. When is this true? When is -6 equal -6? Let me turn it around. When is -6 not equal to -6? Ever? Is it ever not equal to -6? No, it's always. So, when is this equation true? What values of x make this true? All values of x. When is this true? Always. So what makes this equation work? All real numbers. So you could pick whatever the shit number you want to, plug it in, and it will work. Yes?
Is there like a symbol for that, or we just write all real numbers?
Well, I mean, there is. You could write all real numbers, all reals. There's a symbol with an R with an extra spine. I don't know if anybody's ever seen that.
Yeah.
Then you got the really technical negative infinity to infinity, the interval notation, yes?
Yeah.
Oh boy, some people reacted to that strongly. All right. Is that okay? So there are equations that have no solution. There are equations that have infinite solutions. And there are equations that have one solution and so forth. Yeah. Okay, I'm not going to go any deeper into algebra right now. It's coming later. I just want to see if you guys remember any of this. Did anybody remember that could happen with equations? Okay. So if I would have ended up with -6 equals -5, that's never true. So when is the equation true? No value of x. It can't be solved. Okay. I like it. Okay, here's my favorite one. Anybody hasn't talked to me yet today? Did you get an answer for number 4? Yes.
What's 2 plus 1, which is 3, and then plus 2, which is 5, plus
Yes.
3 is 8, plus 4 is 12.
Okay, so one way to look at this is adding 1 to get from 2 to 3, adding 2 to get from 3 to 5. So then if I add 3, I get to 8, and if I add 4, I get to 12. Yes? That is one possible answer. Can somebody give me another possible answer? Yes?
In our group, if I remember incorrectly, we didn't really come to a common consensus on
Sure.
what the answer was. So I kind of went with each new member in the sequence is alternating adding 1 into it.
Oh,
So
sweet.
I
There you
went
go.
plus
Beautiful.
one
I didn't even think about that.
plus 3 plus 1.
So you said, all right, 2, 3, 5. We got you, Jeff. So add 1, add 2, add 1, add 2. Like that?
Yeah.
Totally good. Did anyone else get a different answer? Yes. I'll get to you. I'm sorry. Say again? Oh, okay. So 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. Same one? I'm sorry. You're like, why didn't you call me? I could have got you credit for that. Does anyone know what part of a sequence, what sequence this is a part of? There's a sequence called the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13. It just keeps adding the previous 2 to make the next one. Has anyone ever heard of a book called the Da Vinci Code? It's in there. Unfortunately, it's in there written on the wall above a dead dude, so that's like not the greatest place to be introduced to it, but I'll stop there. The point I'm trying to make with this I'm given some data, and I'm trying to figure out where it's going. If I'm not given enough data, there's a million different directions it could be going. All of these are valid. If this was a problem on a quiz or a test, there would be many different correct answers. Do you guys understand? So you're trying to find a pattern. The funny thing is, very often, there could be multiple different patterns that make what you see work. We just don't have enough information to know which one it is. And that was my point with this problem. Are you guys all with me? You guys doing all right? So you guys look a little pained. I'm sorry. Does anyone have a class on Friday? Anybody got classes on Fridays? I'm sorry, but I don't. So today is my last day of the week. Yeah, okay. So anything else about this sheet here? There's quite a bit on this thing. Obviously, not all of this is going to become immediately relevant. Yes? This is just kind of sprinkled throughout the course. I just want to see where we all were. I wanted you to have a chance to shake some rust off if it's been a while since you did any math business. Okay. So here's what's happening. Well, let me say what's happening today. We're going to actually get into chapter 2. So after today, you should be able to start section 2.1, homework. Remember, if you don't have the book yet, I've got copies of 2.1, 2.2, and 2.3, I think, up in Canvas. If you don't have a book and you're going to be late with homework after those sections, come see me. I can try to help you, yes. But try to get a book. Let me know if you're having issues with that, but try to get a book. We're going to lecture over chapter 2. We're going to watch some videos of little people, little humans. Some of them are in kindergarten. They're freaking cute. They're going to be trying to work these problems out. And we're going to discuss what we notice in the video. You guys with me? So you're going to watch, then I'm going to stop it. We're going to discuss what we see. And then we're going to take a little quick field trip. It's going to be really quick. We barely are going to go anywhere. This is a great day to have a math building so we don't have to walk across the whole campus on a 90-something odd degree day. We're just going to go see where my office is, the Math Science Center, stuff like that. Then we'll be out early. You guys with me? Yay. Good, Jeff. We don't want to look at you more than we have to. Okay. So, we're going to get into section 2.1. So, by the way, I can talk to you guys about this. Do you guys see how I do chapter 2 and then I do chapter 1? Is anyone like, what's up with this guy? Why does he do that? I taught chapter 1 first when I first taught this course. Chapter 1, just to let you know, chapter 1 has got what you would call word problems in it. But they're kind of like, they're not really word problems. You're not going to be setting up equations and solving it. It's just sort of like little problem solving. Like there's different ways to solve these different problems. Are you with me? So we're going to learn different methods to solve problems, and then there will be problems in the homework using those methods. You with me? For me, all I need to see from you is your thought process on how you're trying to work it and where you ended up. Getting the correct answer is, to me, icing. I need to see your thought process. Did you know which method could work? Did you apply that method correctly? Some students were really beating themselves up because they couldn't get the answer. And I understand why that's frustrating, but it's not the point in a way. It's can you differentiate and tell when to try to do what? Does that make sense? So I realized, let me start with chapter 2, because chapter 2 is kind of nifty. We're going to talk about Egyptian hieroglyphic numbers and such. All right, some of you guys freaked out about that, but you're not going to suddenly have to know how to read Egyptian. Yes? I'm going to give you the symbols. You're going to be fine. But that's kind of an easier intro before I slam you with kind of wordy problems. Yes?
Were they meant to get us a head start on chapter 2?
Were you meant to?
Because I did take a look at it.
Yeah.
I hit a wall with the last
I don't blame you.
description, or with the last definition.
So we're going to lecture now. You could always try to get ahead of homework.
Okay.
But if you're ahead and you're having issues, that kind of makes sense.
Yeah.
Because we haven't even talked about it.
Yeah.
And there's a few little details in chapter 2 that some of you guys might have never done before.
Yeah. It's
Okay.
just,
So, chapter 2 starts off all about sets, set notation. And all a set is, if I say the word set, what does that tell you? Does anyone know the game set? The game drives me crazy. When I say the word set, what comes to mind? Where are my tennis players? When I say the word set, mathematically, does that bring up anything to mind? Do you think about?
Group of objects.
Good, beautiful. Group of objects. So a set could be a group of objects. GCAS. We are a set. We are the set of 125 students in Waller's 125 that showed up today. That's the set that we're in. You with me? Okay. So yeah, that's pretty much what it is. It's a collection of elements. So a set is a collection of elements. So I mean, I should have these three. You three are in a set. You're the three that's in the front row on the right side of the room, yes? Okay. Does that make sense? Okay. What we're leading into is students' very first interactions with numbers, correct? And what do you think a little kid is most concerned about at any point? How do I say it so you give me the right answer? Little kid has some time. What does that little kid want access to? Well, everything if you have a kid, but toys, yes? And wouldn't the kid, if he's playing next to somebody else, aren't they gonna look and see, well, he's got more toys than me? That is their very first introduction to numbers, yes? Keeping track of the number of elements. So a set is a collection of elements, and I can talk about how many things are in the set. And that relates to how a student starts to figure out what a number is. How we doing? So, just to let you know, in this class, there's going to be a lot of stuff that immediately applies to what you're going to teach students. But there's also going to be some stuff that you need to know as a teacher that explains how the student is working with stuff. Okay, maybe. So there's kind of a few different levels that we're working on in this class. So watch this. Here's a way to denote a set. Does that look familiar to anybody? Those little squiggly lines? Have you guys seen that before? Sometimes your algebra teacher would have you write the answers, squiggly line, 0, 1, squiggly line. And that means those two numbers make the equation work, yes? That's one place we could use the idea of a set. What are the elements of the set? A, B, and 4. Yes, so there's 3 elements in this set, yes? So if I wanted to say A is an element of set A, this is way too many words for a math person, especially one that writes as poorly as I do. So I'd rather have all of this have a symbol. So this is the symbol for is an element of. A is an element of A. Little a is an element of set A. That little symbol just takes the place of all those words. That pretty much summarizes math. We just made a bunch of symbols that represent a larger sentences or paragraphs of words. All right, how are we doing so far? Yes.
So that sign just means like element?
Yep. This means is an element of. So is B an element of A?
Yes.
So then I could write this. Is C an element of A?
No.
So I would say C is not an element of A. Look how creative we are.
Like, how do I say not? Let's just draw a line.
Not too bad, right? So I could have a set of people and I could say, is Frank an element of this set? You could say he is or isn't, blah, blah, blah. That's the symbol we use to take the place of all those words. Okay. Let me make another set just to make things freakier. Oh, before I do that. All right, okay. If I wanted to know the set of all people in here who are wearing glasses, Could we figure that out? Okay. There would be an answer, correct? I see a few people wearing glasses. I don't mean to point you out. Look at me. There we go. What would be true? Now go with me on this, because I have to make this really silly, because, well, I'll talk about it later. What would the set of all dogs that are also moon rocks, how many things would be in that set? Beautiful. Hopefully none. That would be really weird.
Look at this rock. Oh, holy shit.
So I have to go really silly, because one semester, a long time ago, this is a long time ago now, I don't know if you guys ever heard of the cartoon Cat Dog?
Yeah.
A while back I was like, what is the set? How many cats are dogs? And they're all like, cat dog. I'm like, what the shit? I don't want to talk about the biology of this thing. That's concerning. But, if you have no idea what that show is, you're fine. It's not a prerequisite. So the set of all dogs that are also moon rocks is empty. Neato. The symbol for an empty set is either this, that means empty set, or this, that literally is a freaking empty set. Yes? So either one of those symbols, either one of the symbols tells me the answer is that one. You with me? If I said, give me all the numbers that are both even and odd, you would say empty set. Okay, I like it. Okay. So you'll notice that a lot of these early chapters are going to have a decent amount of symbols and definitions. Very exciting. So now let me make another set. So I have this set, and I'm going to make,
Bless you.
bless you,
Thank you.
I'm going to make 2 more sets. Let me ask you a question. Is set B equal to set C?
Yeah.
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 Yeah. I don't know people's names well enough yet, but I thought that. Go with me for a second. What's your name? Emily
Taylor.
Taylor
Carly.
Carly. If I said, okay, Emily Taylor Carly is in a set, and then I went, no, I mean Taylor Emily Carly is in a set. The same damn thing, yes? So a JSF is the same set as SFJ. So is set B equal to set C? Totally. You with me? So then we can write, thank the gods, we didn't make a whole new symbol for the dumb thing. B equals C, yay. Okay. That we know. Is set A equal to B or C? No. Does set A, so then I could say this. I could say, you're not going to believe this. I could say A not equal to B. That's amazing. Is there a similarity between A and B and C?
Yeah.
What do they all capture the idea of? 3. They all capture the idea of 3. So in some way, they are equivalent sets. They're not equal, they're equivalent. There's a difference there. So equivalent just means they have the same number of elements. You guys with me? A little bit? Some of you guys, every time I ask that, some of you guys are just like this. I never want to play poker with you. When I play poker, you can tell. I'm like, and I lose all my Oreos. It's like terrible. Okay. A does not equal B, but A is equivalent to B. And all it takes to be equivalent to another set is to have the same number of elements. Do you guys get that? The difference there. Equals mean they're the same freaking set. Equivalent means they have the same number of elements. And let me get even more technical with that, because I can't help myself. Plus, I got to tell you about it because it's part of the course. Let's look a little bit deeper into this. I'm sorry, so you guys are still writing. Okay, take it away. Okay, so I've got A is AB4, and B is JSF. My little squigglies keep changing. Let me just say this phrase and see what you think about it. There is a one-to-one correspondence that I can set up between those two sets. Why do they have the same number of elements? For us, you're like, duh, Jeff. I can see it. But from a student perspective, what you guys got to realize, if you're lucky enough, a lot of you guys I know want to teach younger people, yes? The trick with that is, you know a lot of things that you forgot learning. And you'll be teaching a lot of people that have, they're little humans that have no idea what the rest of us humans have been doing because they weren't around. They're not going to have a clue what any of this shit means if you get lucky enough to teach really young people, yes? They have to develop the understanding. We're at a point where we don't even remember not understanding. There's the same number of things. For a little one, they might go, no, there isn't, because one has an A. And you're like, that has nothing to do with it. But from their perspective, they don't know what they're looking for because they haven't had to do it yet. Do you see what I'm saying? So what's trippy about teaching younger is you have to really take yourself out of where you are and say, a lot of where I am is based on stuff I don't remember learning. And that's what they need to get. Okay. So all a one-to-one correspondence is, there's many of them I could set up. I could say A goes to J, B goes to S, 4 goes to F. Did I leave anything out of either set? Did I leave anything out of either set? No. Did I not use something from either? No. Did I use anything twice? That's what one-to-one means. One element goes to another. In fact, I can even do it both ways because that's really what it means. One-to-one means A goes to J, J goes to A. That's why they have the same number of elements, because I can create a one-to-one correspondence. Now that's hyper-technical, yes? You don't have to think of it that way now because you've already learned this shit way back when. You're not going to talk to your students like this, by the way. You're going to set up correspondences for them, and that's how you're going to teach them how to think about things. You're not going to go, well, you have to develop a one-to-one correspondence, Timmy. No, you're going to just do it, and they're going to go, oh, okay. That was fun. That's a little dude. All right. So real quick, if I had another, I already had a C, didn't I? If I had another set that was 1, 2, I cannot set up a one-to-one correspondence. Why?
Because there's not 3 elements.
I'm always going to have one left out, yes? If 1 goes to J and 2 goes to F, well, then S is left out, right? So that's not a one-to-one. I don't have everything in one going the other one and everything in this one going back. I can't set that up so they don't have the same number of elements. Cool. Yes?
Does it matter the order in which you write?
No. I could have put the JSF first. I could have made A go to S. I mean, do you see it? This is one of the correspondence I could have set up. What's another one? A to S, B to F, 4 to J. So in order for them to have the same number of elements, I have to be able to set up at least one one-to-one correspondence. Yeah. You stop for a minute. Okay. Blah 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 blah. Oh yeah. Shoo. Good, good, good. I like it. Oh, that's perfect. Almost perfect. Let me do this. So now we have D is 1, 2. Let me call E 1, 2, 4 W. Yeah. Obviously, they're not equal to each other. Obviously, they're not equivalent to each other. But what do they have in this case? Yeah, they share something, yes? One set can be found in the other one. So the symbol we use for this is really interesting because how would I compare the numbers 5 and 7? 5 is how related to 7? How is 5 related to 7?
Less.
Less than, yes? And we know what that symbol looks like. It looks like an L that fell over for less than. The symbol we use when I have a set that is contained in another larger set, it looks like this. It looks like a less than symbol, but rounded. And you read this as D is a subset of E. Subset, so like a subgroup. How we doing? So it's a lot like a less than symbol, it's just been rounded off. Is that cool so far? Yes.
So, because they are similar with 1 and 2, it would never, it always has to be 1 to 1 with 4 and 4. It can't be like 1 and 2 equals 1 and 2, and then 4 equals W.
No, because that it's got to be 1 to 1 between the sets. 1 goes to 1, 2 goes to 2, 4 goes to oh shit. Then the correspondence is left doesn't work. Yeah.
It's fine if they're not in like the same order, right? Like if it's 1 and 2 and then E was like 4, W, 1, 2. Like it's just. If
Oh
it's
yeah,
contained
totally,
in the
totally.
set. Okay.
This could be in any order as long as this set is contained in this one. Then I can write this. If I had 1, 3 for W, I could not write this because then I don't see D and E. Yes.
I was just making sure subset just means that like the smaller set is in the bigger set.
Beautiful.
Okay.
Subset means I can find the complete smaller set in the bigger set. So, real quick, we are a group of people, yes? Okay. Aren't these guys a subgroup of that group? So if instead I use the language, we are a set of people. These guys are a subset. This whole middle section is a subset. Everybody wearing glasses is a subset. What does that mean? I can find that smaller group in the bigger group. I love it. Kick ass. Kick ass. Okay. I love some of your expressions are like semi-pained, but you're doing okay. Okay. So if I did this, like I said just a second ago, is D a subset of F?
No.
You're not going to believe what I can write then. D is not a subset of F. It just kind of starts to get silly. If it's not, I just put a line through it. Okay, how are we doing so far? Okay, okay. Blah, blah, blah. Oh, here's where things get neat. Do you remember I had B was JSF, and what was the other one? I lost it. C was SFJ. Is either one really a subset of the other? So in one sense, I agree with you. Neither one is smaller than the other one, correct? But do you guys, is 7 less than 8?
Yeah.
Is 7 less than 7?
No.
Is 7 less than or equal to 7? Yes! So, do you all agree with me that those are equal to each other?
Yeah.
I could also write this if I was feeling weird. This just says B is either a proper subset or is equal to C. It's just like less than or equal to. 7 is not less than 7. Bless you. But 7 is less than or equal to 7 all day. B is not a subset of C. But B is a subset or equal to C all day. It means the same thing as the less than or equal to sign, but this relates to sets. Okay. I like to get the feel of how you guys are doing, but your faces sometimes don't tell me. Okay. I got a worksheet, by the way, because I'm throwing a lot at you, and I am aware of that. And I got a little worksheet you guys are going to get to work on together, which is going to be exciting. Okay. Blah, blah. So then, let's do this. Let's talk about finite and infinite sets. So if I said the set of all whole numbers less than 20, the set of all whole numbers less than 20. Is that infinite or is it finite? Does anyone remember what a whole number is first? What number looks like a whole? 0. So whole numbers are 0, 1, 2, 3. Whole numbers are natural numbers, 1, 2, 3, with the number that looks like a whole added on. So whole numbers are 0, 1, 2, 3 forever. So the set of whole numbers is an infinite set, because does that ever end? 0, 1, 2, 3, 4, 5. Could I keep going? Until we all go insane. How was class today? It just wouldn't stop. I think we got to 1,400 just left. Alright. But the set of all whole numbers less than 20, is that finite? Totally, because it stops. So basically, infinite means for somehow it just keeps going. It doesn't have an end. And finite means it does have an end. So, if I wanted to represent this set, this would look like 0, 1, 2, 3, up to 19. If I wanted to represent whole numbers, I would do 0, 1, 2, 3, ba ba ba. The little dots just say, keep going. I'm not going to list all of them, screw that. You guys have seen that before, the little dot dot dots just saying, I've set up the pattern, now you keep going. Okay, I like it. Hey Mikey. The really weird thing about infinite sets. So whole numbers are infinite, yes? What about even numbers? Where would that start? 2, 4, 6. Can you find a one-to-one correspondence between those two sets? Yeah. 0 goes to 2. 1 goes to 4. 2 goes to 6. 3 goes to 8. Could I keep doing that forever? So is there a one-to-one correspondence between the two sets? Yes. So are they equivalent sets? They're the same size. They're infinite, but I can find a one-to-one correspondence. Now that gets a little tricky. Whenever you talk about infinite anything, people kind of go, because infinity is really weird. You doing all right?
Can you like repeat like what it's called? Like they
Re-
correspond with each other?
Remember, if I can find a one-to-one correspondence, like we did earlier, A went to J, B went to whatever. 0 goes to 2, 1 goes to 4, 2 goes to 6, 3 goes to 8, and there's no reason that would ever stop. I can just keep going.
So they're both infinite sets?
Yeah, they're both equivalent. So now I would say, if I call this one W, and I already used E, so I'm going to call this L, just because, then I would say W is equivalent to L. Now W is not equal to L, correct? Why is W not equal to L? Why are they not equal? Say again. Yeah, they don't have the same. Yeah, they don't have the same elements. You with me? And what's really, really trippy. Oh shit. How you guys doing? You guys alright? I just saw some of you guys are like, what? I thought there was gonna be elementary math. What's this guy doing? Alright. This is a little trippy, I agree, but it's not crazy. Infinity always trips people up. It just always does. Understandably, because it's not an easy thing to understand. Let me push this one thing further though. Do you see how I can find every even number in the set of whole numbers? So isn't this a subset of that? Okay, good, good. That's the last thing I'll say. I don't want to freak you out. When you have an infinite number of things, everything is weird. So I'm going to stop right there. Okay. At least in terms of talking about that topic. Don't get excited. We're not leaving or anything. Now. Yes, sorry.
So if you were to answer that question on a test, would you list it as an equivalent or a subset?
Equivalent. You could also, if I said use every symbol that makes sense, then you should also use subset.
So and then you would put like W, that one,
L is a subset of W, not the other way around.
If you said use multiple symbols, how would you do that? Like,
Let me be very clear.
symbols?
I would never ask that kind of question for this kind of sets.
Okay.
Because it goes a little past where we have to be. I just couldn't stop myself. I did stop myself eventually.
Okay, so because those two sets both have an infinite amount, they're equivalent.
Yes, because I could set up a one-to-one correspondence. That's the important.
That makes sense.
You make me want to go one step further now.
I know.
How many numbers are between 0 and 1? Numbers. So 0.7 is a number, yes. How many numbers are between 0 and 1? Infinite. How many numbers are between 0 and 0.1? Infinite, okay. That'll keep you on track. I don't need help with that, Jeff, I'm sorry.
Yeah, that was.
You made me
far.
go. Okay.
That was too far.
That was too far, okay. We're out of here, Jeff. Screw you. Strike! Alright. All you need to do for the homework is understand how to tell if it's finite versus infinite, yes? That's all you need to be able to do. I just went a little further because that's what I do. I'm going to keep doing it now. Let me ask you this. Have any of you ever seen something like this before? No, I don't know. Yeah, sure. And let's say this is 7, 2, 5, 3. Okay. So say D is people that drink. M is people that like mariachi. Think that's how you spell mariachi? It's probably not. I left one of these is doubled, but too bad for me. Have any of you, before you even think about anything specific, have you ever seen a diagram like that? Have you ever seen that type of picture before? Does anyone know the name of it?
Venn diagram.
Venn diagram, beautiful. Can anyone tell me how many total people are in the group that I made this picture from? Say again?
13.
No. Yes. 17. So there's not 7, 9, 14, 17. How many people in my picture, how many people in this group of 17, how many of them both like to drink and they like mariachi? 2. Let me just stop for a minute. Now, please, dear God, I'm asking these questions to see who knows the answers. If you don't currently know the answer, let me know. Do you not see why 2 is the answer? What's true about these 2 people? Which circles are they in? Both circles. What's true about these 7 people? They're only in the drink circle. So what's true about those 7 people then? They do like to drink, but they don't like mariachi. There you go. Of course, the 5 people over there, what's true about the 5 people? They like mariachi, but they don't like to drink. And what's up with these 3 people?
Don't like it.
They don't like it. Okay. The 3 people on the outside, they don't like to drink or like mariachi. Okay. Does that, on the surface of it, make sense? How to read something that's already been created? Well, very excitingly, you're going to get to be able to create a diagram like this.
Yeah.
Yes. Oh. How many people only like to drink? 7. How many people only like mariachi? 5. How many people like both? 2. How many people don't like either? 3. So how many total people? Add up the numbers. Yeah, like it. How many people, now here we go, this is going to get neat. How many people like to drink?
9.
9, beautiful. Because again, there's a circle that represents likes to drink. How many total people are in that circle? 9. How many people like mariachi in my group?
7.
7 people like mariachi. But do you see how the 2 circles share 2 people? Okay, maybe. I love it. You would, Jeff. Okay. So watch this. What if I had a group of people let's say that 8 of them like math, 12 of them like art, 3 of them like both math and art. Yes? And let's say that I have a total of 27 people. Now you're going to have to create your own together. So I'm going to do this with you. How many circles do I need in my little Venn diagram? I only need 2 circles. Because what are the 2 ideas? Math and art. There's only 2 ideas. Will we ever have 3? Hell yeah. Yeah, Jeff. You're becoming more and more popular as we go. Okay. So if I go to create this, do I know that they have an overlap? Do I know the circles overlap? How do I know that? Because some like both. If nobody did, I would know the circles don't overlap. Yes? But these guys do. There's my math circle. There's my art circle. The way that I draw circles, you can tell I'm not exactly an artist. Oh my God, I can't even write the letter M. That's bad. Okay. Now, here's the trick. Can anyone tease out? I've got to be careful because don't the circles share some people? Where do you think I should start? The biggest mistake people make is they'll put an 8 right there. That doesn't make any sense because aren't there going to be some people here? And how many total people are supposed to be in the math circle? How many total people are in the math circle? 8. Okay. Where should I start then?
With both?
Yes. I start with the intersection. I'm going to go ahead and use that word. This is the intersection of the 2 circles, yes? Which is weird that I put this here, but we're going to be okay. Yeah, okay. So right here, what do I put? Right there. 3. Good. How many people are already in the math circle? No. How many people in my picture are already in the math circle? 3. How many total are supposed to be?
8.
How many should be here then?
5.
Beautiful. See that? See? If you start in the middle, kind of spiral out. Like, that's me, Jeff. I'm already spiraling. Stop. So I'm going to put 5 here. Same thing with the art circles. Alright, 3. How many total is supposed to be? 12. So how many are going to be here? 9. So now I can see 9 total art, 8 total math. How many people do I have so far in my diagram? 17. Yes. I have 5 plus 3 plus 9. 17 people. How many total people did I say? Oh, I see. You were 1 step ahead of me, whoever was saying 10. Don't do that. Stay with me. 17 people in there so far. I'm supposed to have 27 total, so how many people are out here? 10. So I get 27 total, yes? Okay. Little Miss ESP, you're ahead of me now. Stop. Okay. Some of you guys look very excited, which is good. Meaning sarcastically, okay. Not too bad, right? As long as you start in the middle, you're not going to make a mistake and suddenly, what I have is people suddenly create other people, which is something we can do, it's just normally not that quickly, right? So I can't make more people than they're supposed to be. And if you're not careful, that's what ends up happening. Okay. Blah, 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 blah. Oh, yeah. So that's Venn diagrams. I got one more kind of set of ideas to go over, and then I'm going to do this worksheet with you, or you're going to do the worksheet. Let's say let's just work with numbers for a second. We'll work with, we'll work with letters. Do those sets have anything in common? Bandy, we have an official name for that when 2 sets overlap. And I already used the word of it. When the 2 circles overlap, what did I call that region in the middle? Intersection. So there's a symbol that represents intersection. So if I say A, this symbol B. this symbol means intersection. It also means and. And do you see how it looks like a letter A that lost its middle bar? Just want to remember that's the and. So the answer to that problem, that is a problem we have to solve. A intersect B, or A and B. The answer is every element that is in A and is in B. So you already told me the answer. What's the answer? BD. So when you see this question, it says, what is in this set and in this set? Only B and D are in both sets.
So like if that's a question on a test or say, would it be wrong if you didn't put B and D, right? Because you're not technically answering what the intersection is.
Yeah, the answer to this question is B and D.
Okay.
So if you wrote anything else, it's wrong.
Okay.
Yeah. Okay. But do you see how that's the
Yeah.
answer? Okay, good. Okay. There's another way to do this. Let me see, how do I want to do this? If I asked all those identifying as women to stand up, yes, and you don't have to. If I did that, and then I said, now everybody who is wearing glasses, stand up. Do you all agree some people who are wearing glasses would already be standing? Because there are some women who are wearing glasses, yes. So I just kind of combined two sets. I combined the set of women identifying as women and the set of people wearing glasses. Yes, I combined them. But of course, when I do that, I can't suddenly make clones of people. If there's somebody who's in both sets, they don't suddenly become two of themselves. So what does that mean for this? The other symbol besides this is, and this is kind of funny to me. I think I asked this already. Does anyone have kids? Okay. Were you a kid once? Okay. Did your mom ever do something like that? I can see my mom doing this when I was little. They're like, Jeff or James, one of you guys clean the damn room? Like this, yes? So this is the symbol for or, right there. So this is A or B. The official name for this is union. The little non-technical name is or. So literally all that means is, what gets into this answer? What gets into the answer? Well, it has to be an element that's in A, or it can be in B. So it literally just write everything. You just don't write it twice, because you can't make a clone of somebody. Who's there? Jeff, and it's like, no. It's only one. So what would the answer to this be? You just have to write everything that's in either one. No, that's the and. That's more restrictive. That says it has to be in both. Or says it can be in either one.
Oh, so
Yes, A, B, C, D, G. You literally just slam them together. A, B, C, D, G. I didn't write anybody twice, even though there were some things in both. Same way if I asked everybody who identifies as a woman, everybody who wears glasses, a woman who wears glasses wouldn't stand up like twice. She wouldn't suddenly become taller or something. Yes? Okay, so I don't write it twice just because they're in both sets. Notice something. And makes things smaller because it's more restrictive, or makes things bigger because it's like, So an example I'd like to give, I give two examples. Anybody ever applied for financial aid? Okay. Back in the day when Jeff was in college, in like the 1840s, you would go to the financial aid office and they had this book. Yes, this is before the internet, or like the internet was just coming up. You go in there and you crack the book open and you start to read. To get the scholarship, you must be a math major. Check. You must have this thing. Check. And then at the very end, it would say you must be more than 30% Cherokee Indian. I'm like, because it was and this and this and this, and then the number of people were getting smaller and smaller. Yes. Another example I like to give is go to a bar. And there's a guy at the front door. It's like a club, not just a bar. So it's like, all right, to get in the club, you have to know Joe the bartender. I know Joe. Hey, Joe. And you have to have a lot of money. I'm screwed. And I'm already screwed. You have to dress nice. All right, fine. If I go to another bar, or there's another person out front the next day, and he says, okay, to get in the club, you got to know Joe. I know Joe. Hey, Joe. Or you have to be rich. Okay. Or you have to dress nice. All right. I know Joe. I can go in. So, or makes more people able to get into the answer and restricts things, make less people be able to get in there. Does that make sense? And the word intersection, where do these intersect? B and D. Bless you. Union means unite the two sets. So you can kind of think of it that way too. Okay, maybe. Maybe? You guys really like that one, okay. All right. Bless you. Oh, I do that. Okay. One last thing, and then I'm going to finally shut the hell up. Well, maybe two things, sorry. If I said A was 1, 2, 3, and B is 2, 4, 9, 10, there's one type of set I haven't talked about yet, and that is the set of all possible things. We normally call it U for universe. So A happens to be 1, 2, 3. B happens to be 2, 4, 9, 10. And then this tells me what they could have been. It's like U is the set of everything they could have picked. And A picked 1, 2, 3, and B picked 2, 4, 9, 10. Were there things that neither one picked? 0, right? Did anyone pick 0? So, this is all the choices you have. If you go order some pizza, are there certain toppings you can choose? What's happening? Pizza. Everybody imagine pizza. Are there certain toppings you can choose? Do some pizza places not have toppings other pizza places have? So then their U's would be different. One pizza place's U might be bigger than another one. Like these guys offer broccoli, the bastards. And these other guys don't, right? So the U over here is bigger. It's got broccoli in it. The U over here is a little smaller. It doesn't have broccoli. You guys with me? So U is just all the things that could have been in the set. What ended up in A? 1, 2, 3. What ended up in B? 2, 4, 9, 10. And I can ask you about the intersection. I can ask you about the union, but I'm going to ask something different. I'm going to ask, what is not in A? So that symbol there means not in A. Now, without this, your answer would never end. Because 11 is not an A, 12 is not an A, 13 is not an A, 14.9873 is not an A. No, but thank God I got a universe of everything that could have happened. So what is not in A? Give me something that's not in A. 0. Keep going. 4.
5, 6, 7.
7, 8, 9, 10. Those are not in A, correct? Do you see that? Okay. Without the universe set there, that would never end. It would just be every number that's not in A. I'll just drive us all insane. And I'm already driving us insane without that. Yes?
How is there a 0 in the U set if it's not in A or B?
No, you're thinking of this backwards. U is the big thing of toys. A is the one kid. I pick this one, this one, this one. B is the other kid. I pick this one, this one, this one. And maybe they share one. That's why they both want to do. And so are there stuff left in the crate? Yes, those are the ones neither one picked. So what toys did the A kid not pick? Those.
Okay.
So that's the total things that could have been in a set. And I can see what actually made it into the sets. So, who could get a scholarship? All Grossmont students. Did every Grossmont student get a scholarship? Probably not. Yes? That makes sense? So like, I could have a set of all the people that got this scholarship, a set of all the people that got this scholarship, and then there'd be a set of people that aren't in either one of those. They didn't get either one. Yes?
Is there a reason why you added like certain numbers and not other numbers? Because there's no like 5 and 6, but like.
No real reason.
Okay.
Same reason I made this 2, 4, 9, 10. Just out of nowhere. Yeah. Is that alright? So again, this is just trying to get the idea of not A. This is not, you're gonna have to create a set based on anything. So what did I do? I just made shit up on the spot. Just so I can talk about this idea, right? So you're gonna be given this stuff, and then you can answer this kind of question. Okay, good. You're not gonna have to create set U from somewhere. Yeah.
I had to talk about it. So in set A and B, the numbers that are in it, in the one that says U equals, why does it start with a 0?
Because it won't, because it does. So if I had
Oh, I get what
if I had a chest of toys, yes, can you see it? I have a big thing of toys, and I'm looking at it. I'm like, why is there not a transformer in here? Because it isn't. Why is there a little bubble mower thing in there?
Okay,
Because
so
it is.
it just represents what isn't.
This just happens to be the stuff that was available.
Right.
A picked those, B picked those.
But why is there a 0?
It's because
You're thinking of it
So
backwards.
it's what wasn't like it's what wasn't in either of the sets.
No, 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 no.
U was given.
Alright.
Right.
U is there.
Yeah.
And then A picks from you, B picks from you. So could they have picked 0? Could either one of them have picked 0? Yes.
Yes.
Could A or B have picked 11? Could A or B pick 11? No, why not? Not in the universe.
Yeah.
It's not something in the toy box. What's in the toy box? 0, 1, 2, 3, 4, 5, 7, 8, 9, 10. What did kid A pick? 1, 2, 3, because that's his favorites. Kid B picked 4, 9, 10, and then he's going to share 2 with the other kid because they're friends. And they both like 2. You with me? Okay, does that make more sense?
Yeah.
And do you see why I need a universe? Because otherwise this question would never end.
Yes.
The answer would never
Okay,
end.
yeah. So you would never see it without the U?
Yes.
Okay.
Yeah.
Does U like stand for universe or is it just a random letter?
U stands for universe.
Okay.
And one thing I didn't say earlier, the little box I made around the Venn diagram is the universe. And in the universe, there's people that like mariachi. Oh no, what was this one that came out? Oh, math, art, and they don't like either. So this is kind of like the 0 is out here because they didn't pick, neither one of these picked it. Yes, okay. Now here comes let me push my luck. Yeah, I think, yeah, I'll do that. Because I feel like, let me push my luck. One thing. All right, this is a little trippy. A minus B. What in the hell would that be? A minus B. Yeah, everything in A that is in B, I take it out of A. So there's no like negatives or shit. What's the only thing in A that's also in B? 2. So what's A minus B? What's left? When I take everything out of A that's also in B, what's left? 1 and 3, done. So in terms of sets, subtraction doesn't lead to negatives. It just says whatever is in both comes out of that guy, and then you write what's left. A minus, all the stuff A has, that's in B. That's what that means. All right, now. I think I should stop there because I've really loaded you down with a lot of ideas. So what I want you to do, I'm going to tell you which one of these not to worry about yet, because I'll talk about that later. We'll give these out. The what now? Oh, no. I gave you authorization. Right? You gave me your student ID earlier. So you should be able to enroll. If it's giving you issues, then you might have to go to admissions.
When you give it to me, it's sent me an email. And I didn't have to do anything. It was just like an email.
Or I might not have enough because I had several people suddenly appear. Let's see if I have enough. I think I have enough. So what I want you guys to do. Okay. And let me just say this. Whenever I give these kind of worksheets out, is this a quiz? No, is it a test? Am I ever gonna have to see this at all? Every time I walked around, you could have hid it from me if you wanted to. That's fine. You with me? When I give you this kind of worksheet, I'm not saying, oh yeah, this is shit you should know by now. Do it now. No. This is struggle with this. Try to apply what I talked about so I can see what didn't get through. So I had just talked about this stuff, and I just wanted to see how much kind of like made it through. Get off your own backs. We just talked about this. So I'm not saying you're supposed to, you're supposed to know this. No, you're not. We just talked about it. I just want to let you play with what we just talked about a bit. So some of you guys, I think, are thinking you're supposed to be able to do this. No. So this means A and B. So to be in the answer, they have to be in both. So I think everybody I saw pretty much got this. What is this one? What numbers are in both A and B?
7 and 26.
7 and 26. Kick ass. So that, again, this symbol, and, will always make the thing smaller than what it was to begin with. Yes? This one is just everything that could have been in B that isn't. That's not B. So what is not in B that could have been there? 0, 3, 4, 18. Good. So now we know what not B is, yes? We just wrote it for ourselves. So now this question says, what is in A or in not B? So here's a really dumb way to do this problem. You ready? Everything in A is an answer, because everything in A is in A. How do you get to be the answer to this question? You're in A or you're in not B. So everything in A is automatically an answer. So the way I do this kind of question is I pick a set and I go, I'm just going to write all this shit. I don't have to think about it. All of this is an answer because they're in A. What am I missing that's in not B?
0 and 3.
Done. So your answer has to have both not B and A in it. I'm unioning those. I'm uniting those two sets. That's why we call it a union. What did we just say? 0 and 3. Yes. Cool. This one again, this one means everything that's in A, take away whatever from there that's also in B. So what would I lose? Good. So then what's left? 4 and 18. Kick ass. Okay. Yes.
For the second one, why would 26 not be in it? For not.
Oh, because 26 is in B. So it can't be in not B. Yeah. Good. Don't worry about this. We're going to talk about that next time, apparently. Don't worry about this. Is 4, what does this say in English?
4 is not an element.
4 not an element of not B. That's exciting. Is 4 not an element of not? Well, is 4 an element of not B? Yes. So is 4 not an element of not B? No. Good. So you can say false or no or no. You with me? Very exciting. English, double negatives don't matter in math. We're cool with it. This one's nice, yes? I ended up with a nice one. What does that mean again? Equivalent. And what does it take to be equivalent? Same number of elements. So is A equivalent to B?
Yes.
Totally. They both have 4 elements. Yes. Okay. How we all doing? I think I got most of you guys there that I was helping. Let's do number 2. Yeah, I think we can maybe make it through this. We got 38 total people. That's good to know. Don't have to worry about that for a bit, though. How many circles do I need in my Venn diagram? 2, because I have 2 ideas. What are the ideas? Left-handed and artistic. Artistic, be careful. Where do I start?
Intersection.
Good, in the very inside, yes? How many go in the intersection of left-handed and artistic?
3.
Yeah, 3 people are both. How many are already in the left-handed circle?
2.
There's already 3 in there, yes? How many is supposed to be total in there? 5. So how many go there? 2. Kick ass. I mean, do you see, if you spiral out from the center, you'll be golden. You're supposed to have a total of 19. I have 3, so of course there's 16. How many people do I have so far? 21. And I'm supposed to have how many total?
38.
So how many are out here in the universe? 17, just floating out there. Okay. Kick ass. All right, let me see. Shoot, I gotta hit the road. Let's do this first one here. A intersect B. Literally, I had a few of you guys just draw 2 circles, and I said shade in where they intersect. So what's in the intersection of A and B? Where do 2 and 6? Yes, 2 and 6. That's in the intersection of circle A and circle B. What is in circle B or in circle C? So now you start to see the silly way to do this. I'm going to just put everything that's in B. 2, 6, 7, 3. Now what's in C that I haven't listed yet? 5 and 4. That's the quick way to answer a union question. Pick one of the things, put them all down there, and now just write everything you didn't include yet in the other thing. The answer has to end up having both in it. Just no repeats. Okay. And then one way to answer this question. 5, 6. What's true about 5, 6? Just by itself, 5, 6. It's like A intersects C, yes? So this is A intersect, you could do it, Jeff, C. What's 6 and 2? A intersect B, yes? Just like we saw up here. And if I just union those, I'll get 5, 6, and 2. Now that was tricky. Sorry. If I can get 5, 6, and I can get 6, 2, I can just union that shit and I get all of them. Because union takes everybody that's in either one. Y'all look really excited about this. So obviously, we're going to go a little deeper into this. Right? Next time. We're not done with 2-1. But what I want you to do, can everybody do me a really big favor? Pack up all your stuff. You're going to walk this way very slowly and wait for me to get in front of you, yes? Okay.